Hello, welcome, AirShot Live, Sean Hanrahan here. If you're watching this video, it is because you are looking at setting up a partnership with AirShot Live and you want to know how AirShot Live can help your operation. And today I'm here to show you just one aspect of this partnership and how it can benefit you as a commercial and even a residential roofing company, but primarily a commercial roofing company. So we do offer a lot of different types of technologies that essentially can help you in every step of the process when it comes to implementing a new roof, whether it's from the sales process to implementation, from logistics, getting everybody on board as far as the project manager and the estimator, having everybody on the same page, looking at the same information, having multiple sets of eyes, and kind of a checks and balances within your organization. So obviously, from the sales aspect, when we come in, we are able to provide a complete thermal analysis of the roof system. What this does essentially is it isolates, or not isolates, but we're able to identify areas of wet insulation underneath the membrane. The benefit to this, obviously, is that the customer doesn't have to play guesswork. You come in and you've got a 100,000 square foot building that you've quoted the job out for 500,000 at $5 a square foot. I'm just using simple math here. I'm not really sure what your pricing is, but and you tell them, hey, it could be $5 a square foot, could be 500,000, it could be a million if all of the insulation underneath the membrane needs to be replaced because of saturation, or it could be $2 million, depending on whether or not the R panel decking underneath it also requires replacement. So our goal is to go in and, based off of information that's provided through core samples, you'll still need to do core samples. Whether you're doing a core sample and we're suggesting an area, or you go in and you find a wet area, it just completely depends on the project. But if you're able to identify a specific area that had a core sample, and that core sample was indeed a saturated location where the ISO or the EPS underneath has been saturated, what we can do is we can take that area, identify the heat signature, and then essentially locate other heat signatures that are similar, and we can assume that those areas are wet. So that being said, from a sales standpoint, that is it's a huge benefit to be able to go in with intelligence without having to do core samples and moisture samples, or moisture tests throughout the entire roof, and potentially leave the roof susceptible to additional damage. So that is a huge benefit for the sales team. Also included in the sales process, you'd be able to pull up the 3D model, show that to your customer, and just it makes it a lot, I guess, more clear what it is that you're looking at doing and why you're doing it. Now, moving forward, when we get into the creating a 3D model, the benefit to this 3D model is that we are able to create a 3D model which your logistics teams, for loading the roof and unloading the roof, loading the job boxes, loading the materials, they can use this accurate 3D model and be able to accurately place the materials and place the job boxes in the locations that the foreman is requesting. The foreman's able to take a look at the 3D model and identify locations that might have some difficulty, identify where they'd like to have the materials loaded. keep in mind, you can do this off of Google Satellite if the satellite image is there. If the satellite image is current, it could be a scenario where you've got a 5-year-old satellite image and things have changed on the roof. You're also able to pull some of that information off of Google Earth as well. It's not the same as using a 3D model in the sense that that 3D model then is it's one that can be collaborated with the operations team, logistics team, the foreman, and also most importantly the estimator. So what we provide with a complete 3D model and a roof takeoff, digital roof takeoff, would be going in and actually identifying the penetrations, the stacks, the sleepers, the curbs, how many linear feet we have of the actual of the flashing, the coping flashing, etc. So just to kind of dive into this, I think what we'll do then is I'm going to go ahead and just load up the screen, and once I load up the screen, I'll be able to show you what we're looking at in the software, and that way it gives you a better idea of what it is that you'll be looking at. So if we turn and look, we can see the screen up here. This is the DJI Terra software. This software is essentially used after we get the drone, after we run the drone mapping mission, the 3D model mapping mission. We're able to upload this into the DJI Terra software and then begin to analyze the roof system. So looking at this, we have a 2D, we got a 2D model. You can see all these little dots right here essentially identify where the camera was when it was taken. And as we zoom in a little bit more, those dots or those camera angles, they begin to change. So from the 2D, we can do a lot of different types of measurements. We can perform, go up here and we can perform an area measurement, which is great for your estimator when your estimator is, determining how much membrane we need to order for this job. And, once we do that, we've got a project area right there. We can see that that is 2918 square feet. So if we come down here, we can then, off of that, we can create an annotation. And so I'm going to go ahead and create an annotation of that area. And then we are going to add that to the annotation. And we're going to call this section 1. Section 1. We'll say, it normally when you're going to be estimating, you would estimate 29 square feet. Depending on how you do your estimating, what we'll deliver is the actual square footage. So if you want to take a look at our actual delivery of what the square footage is, and then add 10%, 15%, whatever it is that you do, whatever your equation is. But we'll add the actual square footage. So at this point, I'll put section 1, and just as a note, I'm going to put 2919. So I know that that's 2919. I'm going to save that, and we can see over here in this section. Then I'm building a CSV file that is going to give me a list of all the square footage that I have. So let's go over here, and we're going to actually create another annotation. So we're going to go over here, 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 and I'll go here and there. And now we have another one. And we're going to call this one, we're going to save that. We're going to call that section 2. Section 2 at 5405. I'm going to save that, 5405. And then I'm going to create one more. Obviously, we want to make it all the way through this roof. So I'm going to go ahead and here. Oh, we can move that a little bit since it wasn't exactly right. And we'll go here. One more. And we're going to do one more right there. And let's go ahead and name this section 3. And we've got 38,924. We'll save that. And finally, last but not least, we have section 4. Let's move that down a little bit. I think we're off. And we got 10,000. $92. All right, so we have essentially created a list of the square footages that we are going to use to order our material. And so obviously walls, you're going to go up walls, and the wall you might have, depending on the length of the wall, you might have an additional, per linear foot, an additional square foot as well. And on this particular building, we'll be able to see the walls when I go into the 3D model. But I just created an Excel spreadsheet. And what I'm going to do then is I'm going to go ahead and save that Excel spreadsheet. And we'll go into a drive here. Let's go into Roofing Example USA. And then I'm going to go in here, create this file, hit new folder, and we'll say square foot report. And we're going to open that up, and we'll save that. Now, we have a square footage based on a 2-dimensional drawing. And that's neat. You could probably do that from Google Earth too. That takeoff is, basically something that you'd probably be able to perform off of Google Earth. Now, where the 3D model that we're creating comes in and really differentiates itself from being able to do a takeoff from Google Earth and going into an actual takeoff is we can go into the 3D model now. And when we zoom into that 3D model, we can really see how much definition we have, what we have. So we can see that this air handler right here it's on sleepers. It's not a curb. You couldn't see that from Google Earth. So if we were to look at Google Earth, maybe we could just pull up a comparison here, and we'll see what Google Earth might look like in comparison to the 3D model. So I'm going to go ahead and pull this up, and let's go into Google Earth. I believe this was 802 Estes in Chicago. I was just there. Oh, that just pulled me up to De Pere. Let's go Chicago. No, let me pull that up here one more time. Let's see what the zip code was for that. Give me one moment, please. $60007. There we go. All right, so Google Earth is, 'cause, 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 ' No, that's not it either. Huh. Having some difficulty here getting the. It's Elk Grove Village. That didn't work. Let's see here. Oh, it's because it's 801. That's why. There we go. So we're going to go ahead and go to 801. Yes, right across the street. You'd think I would have been able to do that, but I wasn't. So if we go into here and we go into Google Earth, we can see, I'm going to go ahead and expand this out so you can see. Google Earth does not show anywhere near the amount of detail. You can see that there's a unit there, but you have no idea whether or not that unit's on a sleeper, whether or not it has a curb, if that curb is 6 inches, if it's 12 inches, none whatsoever. You look at Google Earth and compare, you can make out that's a skylight, you can make, or that's a skylight, and, you can get some rudimentary measurements off of Google Earth too, so very similar. You can get the same types of measurements. How accurate are those? Not always the most accurate, because there is a differentiator between 1 foot and 2 foot. So sometimes you line up Google Earth and like, hey, it is taken, but it's actually taking it from the ground because I was off just slightly rather than taking it from here. So there's quite a few differences between Google Earth and a 3D model. Google Earth is great for looking and getting an estimate, but if you actually want some accurate readings, you're going to want a 3D model that uses RTK, GNSS, global positioning systems that essentially pinpoint where where the penetrations are, how big they are, what their elevation is, and that type of thing. So we do a lot of work with solar companies and a lot of work with different types of commercial roofing companies as well. But so I'm going to go ahead and minimize this screen and get back to the 3D model. So we go into the 3D model. Now that is really just fantastic what we're looking at here. So if I want a measurement right here and I want to see how big is that, how big is that sleeper, I can see that sleeper is 0.39 feet, so 0.4 foot. And if I want to see how tall that is, I can see how tall that is as well. So I want to see how wide it is. I can see how wide that is as well. Now I'm looking over here and I can see that the electrical is, we got electrical here as well. I can go over here and I can see I've got a curb. And if I want to get a measurement on that curb, I can go ahead and get a measurement on that curb as well. So if I want to see how high the curb is, we can see that is, 0.65 feet. So, it's roughly 0.6 of a feet of a foot. We can build this out as we go if we want to. So if we want to start logging these, I can name them. Like this one could be curb 1, or we could just label this C1. And we got the measurements. We're going to save that, and then we're going to see, what the area of that is as well if we want. We can say that area right there. And that being said, we can even document that. And we could name that C1. Save that. And then we have the area, and as you can see, as we build this out, we can see an accumulative, square footage reduction, drastic square footage reduction. So when we're ordering now, we can go in and essentially build out all of the penetrations on this roof, and we can see the curb height. So if it's a 1/2 foot, and it is, length times width, we can add a 1/2 foot, and then we can reduce the actual space for the membrane as well. and we can get an even more accurate estimate of how much membrane and how much waste we have or should have based on our digital takeoff that we're providing. So the digital takeoff essentially in tandem with your estimating team, we create a CSV file that marks out all of the penetrations, what their curb length times width is, what their curb height is. We can even go into the 3D model, and as we kind of turn around, this model was not made specifically for a facade or for the side of the building. So if I were making this model for a facade, say you did clad, or you wanted to get more accurate readings for the metal detail, the coping, the flashing, and that type of thing, we would perform a different type of a flight pattern, which would definitely give you more detail. But even on this 3D model, if we look, I'm going to go ahead and stop this. Even on this 3D model, if we look, we can see we've got some tenting on this EPDM. So that obviously is going to be a trouble area. So if I were to come in, and I know that there's going to be condensation buildup in that area, because in the winter months, obviously there's going to be air in there. That air is going to create a vacuum of moist air, cooler temperatures on the interior, colder temperatures on the exterior. Ice is going to build up there. So I know that this area is going to be a wet area. I can tell that. And so when I come in and I provide a thermal scan of the roof for your sales team, I'm going to say, hey, I'm going to guess that this area is going to be wet right here. And I'm going to say, hey, if you guys could do a core sample right in this tenting area so we can get a temperature reading on that, then let's do that. Once we have that temperature reading in that area, we're going to be able to isolate, essentially what we're looking at for other areas at potential wet insulation removal and replacement. So I'm back to the takeoff here. We can see here that we've got a difference. We've got the membrane that's running up this wall, and that membrane is running up above the termination bar. But if we want to get a measurement on that wall right there, very easy. All we're going to do is take a measurement right here on this corner, and we know that that wall right there, or that distance, is a foot and 1.2 feet, and it probably goes up a few inches above that termination bar. But you obviously might want to bring it down. However your foreman wants to install that, but now he's got an accurate reading on what the current termination height is for that EPDM running up the wall. Same is true for all your penetrations. So every single one of these penetrations, we can get a reading at how high up are these going. So you're not going to get that on Google Earth, that's for sure. You're not going to get anywhere near that. You're going to get a blob on Google Earth. This penetration over here is going to, we're going to take a reading over here. We want a measurement, so I'm going to measure, and we can say right there. And again, we got a measurement right there, 0.65. And as I'm building this out, I'm going to be labeling these and generating a CSV file. So at the end, that CSV file, you can essentially look at it and you can say, okay, I've got 100 penetrations. I've got 100 stacks. I can even turn and look at this from a two-dimensional if I wanted to. And if I wanted to get, a two-dimensional diameter of this pipe right here, I'm going to go ahead and go two-dimensional and build out a diameter of that pipe. So now I can build out, just for my stacks, I can build out a CSV file that has all my stacks. I can build out a CSV file that has all my curbs. I can do it all in one. I can do it separately, and that kind of depends on how your estimating team, how they stack up all the components of the roof. But we can certainly accommodate whatever you're looking at to achieve and how you're looking to achieve it. So now, kind of going back to all the way from the sales process to the logistics, to the implementation team, to the installation team, and even to the cleanup team. You know, where are we going to place we're going to place the job boxes when we're done? Where does the crane go? You know, are we able to set the crane up here? And if so, you know, what do we need to do as far as the crane, as far as coning off the area? And, you know, now we can collaborate back and forth with our teams, but then also collaborate with the maintenance team on site, you know, with the property owner, with the operations manager of the customer. And we've got some really good information and really good data that we can share with them. Hey, we're going to need this much space in this corner right here. In order for us to set up our crane, we're going to need this. This has got to be, you know, tied off, or this has got to be coned off for X amount of time. And, you know, just start to finish, you've got collaboration detail that you're able to use, you know, from the sales team, implementation team, estimations, or from the estimator, from logistics, from the foreman, even down to the guys that are going to be vacuuming off the existing ballast stone, and you know, the guys that are going to be installing the new heat welded TPO system, whatever it might be. So once again, I certainly do look forward to working with your team in the future, working with whether it's your sales team, whether it is your implementation team. Keep in mind, we've got pilots throughout the United States, so essentially gathering the data is a pretty easy process. Lead times are dependent on weather and availability. For instance, if we've got a project in Houston, and you're looking at getting some 3D data for you, and you want a digital takeoff, and you're looking at getting a thermal scan for your sales team, and you know, let's say I've got a guy in Dallas and he's not available. Depending on how fast the project is moving, we'll accommodate for those types of overlaps or those types of areas that we may not have coverage. Building out our team, I've got a team that's growing, and you know, by the end of 2025, we are on task to have a pilot for every state. So as your projects come in and you find the usefulness and the effectiveness of this digital platform, implementing it into your sales, implementing it into your processes, you know, we'll grow with you as well. So once again, thank you for your time, and look forward to working with you. Remember that AirShot Live, if you do have any questions or you'd like to just get some information about us, www.airshotlive.com is where we can be found. And have a great, safe, incredibly productive day.